Okay, so good evening and welcome to another lecture, I guess. So first things first, tonight the group thing closes, right? So as far as all the registrants are considered, I think 37 students have selected a group until now. So we are essentially left with just one student, if I am not wrong. So the total participants are right now 40. So that's including me and the TA listed in the participants. So that is like 38 students right now. And if we look at the group selection, then we have about 37 students who have registered. Okay, so that's, yeah.
I got a friend who's in the waiting room and says.
Drove?
True, yeah.
Okay. Okay.
Thanks.
Yeah. So as the situation stands right now, there's just one group. Is name here or Christopher? So probably that last student will go in your group. That will give you a minimum of 3 students, essentially. Unless any of the existing 4-member groups want to. Do you guys want to stick together?
Yeah.
Okay, never mind. So anybody, I'll find out who that is, who that person is, and I will email you guys and ask them to just select your group. Okay. All right. So that takes care of everything else. So going forward, please make sure that you discuss amongst your group members now. Consider all the rest of the groups to be final. There won't be any changes. Please select a project topic and please select your research presentation topic, research paper presentation topic, and 1 registrant per group. Okay, just make sure everybody does not submit a response to that survey that is open for project topic selection and research paper selection. So decide who is going to be the representative for your group, so to speak, and let them take care of the task. Just make sure that they are on time. That's the more important thing. Okay, so as the group selection closes, I think there is nothing much to do right now for 99% of the class. Your next focus should be here, which closes January 29th. I believe that's the end of the week, if I'm not wrong.
Yeah, I think that's right.
Yeah, we'll give or take 6 days from now. Okay, so please make sure that you submit your topic. There is a penalty that is associated with it. So I will check it exactly after midnight. Trust me on that. I stay up all night, so more or less. So don't be like, he's going to check the next morning. No, I'll check it then and there. Okay. So this is just a fair warning for everybody who wants to like gambling and stuff like that. Don't gamble with me. So there is a penalty. That's what I was trying to kind of get towards, is the fact that you lose 2 points from your original assignment if you do not select your topic by the deadline, right? And that kind of will be applied. The penalty will be applied for like up to 96 hours. And after 4 days, even if you have not still selected any topic, I will give you one of my own liking, right? So again, don't leave things on my hand. That's the thing that you have to keep in mind. Okay. And again, remember, for project topic, no problem if multiple groups select the same topic. I don't have any problems with that. Research paper presentation, I believe there are 20 options that are available. So try not to have an overlap. What I will do is after today, I will check whatever submissions have already been made for research paper presentation, and I will put that up on an Excel sheet that is accessible to everybody. So if you are contemplating what kind of topic to select for the research paper presentation, then you can simply just check all the existing selected topics and try to choose something that is not one of them, right? So that will kind of keep things even. So yeah, so any questions regarding anything? Is everything clear? So yeah, so that's what it's there where we stand for the semester long tasks. That is going to be the important ones. Because a lot of your points is kind of consolidated on those two major tasks. So kind of keep an eye out and make sure that you are, performing or doing your part, whatever the group assigns and stuff like that. Because if you slack off on that side, either two things will happen, either you will lose a lot of points or you will be stressed out. And either of those options are not favorable in your situation, right? And of course, we talked about the quiz. The quizzes will start coming up soon because we are almost probably will be done with computer clusters today. That's the end of more or less half of the first module. And then we will begin about virtualization and stuff like that. So the idea is for the quizzes, as we discussed in the course overview lecture video, is that I just want to make sure that you're aware of the key highlight topics of each chapter that you cover, so that regardless what you remember, what you don't remember, you at least remember those few things, right? So the idea of the quiz is not to test you, so to speak. It will be short in nature. It will take 15 minutes if you sit down and attempt it. It will be MCQ in nature or very short answer type questions, right? So the goal is not to, put you up to a challenge. The goal is to help you kind of revise the chapter, help you understand whether you have learned something out of the chapter or not, or whether you need to revisit the concepts and study again, right? So that's the whole point of it, okay? So that will be uploaded on Moodle. That needs to be answered on Moodle again, all right? And again, as a suggestion goes, please try to do it after every chapter. The whole purpose of the quiz is defeated if you decide to do it in bulk towards the end of the semester, right? Either you won't remember anything at the end of the semester, you will have to go back and revise again, which is not a bad thing for me, but it's up to you how you take up on your tasks, right? Yes.
Are those quizzes single attempts or multiple attempts?
For now, single.
Okay.
Right? Single is the way to go.
Yeah.
Okay. Yes, ma'am.
Are you gonna put like just a deadline for the quizzes?
I don't want to at this point of time. I want to see how people are, attempting the first quiz. If I see a lot of people, reverting back to their, so to speak, innate instincts of being a student, that is to delay, then I will put a deadline just to make sure that you don't, cause yourself pain at the end of the semester, right? So for now, I will give you the benefit of the doubt. I might have to give a deadline depending on how the nature of the assignments are, but you don't have to stick with it as such. Because as I said, this is not a challenge. This is not an actual exam as such. This is for your benefit, right? So if you do it, you will benefit from it. And in the meantime, you can also make some points out of it. So think about it that way, right?
Yeah, just like the deadline out.
Yeah, suggested deadline, I can give that. Yeah. I can give you this. Yes, sir.
Are they closed book, open now? Does it
I don't
matter?
care.
Okay.
It's up to you. This is an part online course, part fully online course. So proctoring uniformly across the board is difficult. So for everything, it's open book. Let's put it this way, right? And again, wouldn't want to use the heavy words right now, but if you cheat, that's on you. I have nothing to gain, nothing to prove here. So you decide what your future is going to be like. I have no concerns there, right? I will tell you, I will do my part, tell you not to do it. Everybody does the same thing. They tell you don't cheat. Be sincere about your assignments. It's up to you to make that choice. Because eventually there will come a time when in work, there will be no solutions, no reference of any sort. So if you develop the habit right now of cutting corners, nobody's going to bail you out at that point of time. So you decide what you want to be, 5 years down the line, 10 years down the line, and what kind of habit do you want to have? That's all I have to say. That's a passive aggressive way of putting it, but if it gets the job done, well. Okay. But don't be so morbid. Take it as a positive thing. Everybody gets kind of tense when cheating comes up and stuff like that, right? And for project and stuff like that, it's how much effort you put to learn something. I personally believe that the time I spent developing the assignment, coming up with the topics and stuff like that will actually help you in real world. Now it's up to you how much effort you want to put it to dig up all the information that you can in that particular subject or topic that you choose, right? So all the topics are trending right now. That's the language we understand in this day and age. Viral is something that I will not use anymore. I had enough of it for the last 2 years. Don't want things to go viral anymore. So anyways, so that's the gist of it, and everything else will be smooth sailing. Okay. In-class demos and stuff like that, practice it just so that you're ready and stuff like that. All right, any final questions before we get on with our discussion? No? Anybody wants to tell a joke? No, nobody has a joke.
You guys should credit for telling a joke.
If everybody laughs, and those who don't laugh, I will give them the credit. So let's see how game theory goes here. Anyone? No? So tell me, why did the zombie not eat the person who didn't have any feet? No?
No.
Because that zombie was lactose intolerant.
That's good.
It didn't resonate that way, but okay, I'll take it. Sal has always been there. So
There you go.
all right. So just to quickly recap, we were just discussing about the architecture of computer clusters, right? We talked about the motivation of how computer clusters came into being and stuff like that. And we discussed about the design challenges that you have to keep in mind when you're working with computer clusters, and then the different types of computer clusters that you can effectively formulate when you go forward with those design issues in mind, or when you try to address the design. So where we stopped last time was essentially with the discussion that if, let's say, you are an architect, right, and you have to decide for your organization whether you should design, let's say, a dedicated computer cluster or an enterprise computer cluster, where essentially, if you're using a dedicated cluster, you have compact structural, compact packaging, right? You have centralized control, like the administrative aspects are all centralized in nature. And then if you're looking at the other side of the spectrum, which is basically enterprise clusters, then you're using typically the Slack cluster packaging technique, okay, where everybody is kind of contributing their own computer systems, which is heterogeneous in nature, different platforms, stuff like that, but they are all a part of a cluster, right? And they can be assigned different jobs depending on any kind of space that they have with themselves, right? And the control for that kind of structure that kind of design can be central in nature, or it can be decentralized in nature, where all the individual owners of the nodes will basically have their own autonomy. And the discussion that we were having, or we started off with, is if you want to make a decision, right, a scientific, factual-based decision on whether to build a dedicated cluster for your organization or whether to go with an enterprise cluster architecture, then how would you solve that problem, or how would you even approach that problem and make a scientific formulation for the decision-making process, right? And some of the suggestions that we got towards the end from the audience is basically, how often do you want to perform computationally intensive tasks? That would play a factor in deciding whether you want to use dedicated versus enterprise, the number of users that you're trying to support. And then finally, at the end, how do you want to administer and deploy these different nodes that will be a part of your cluster? And then we ended the class basically with adding the factor that money is one of the important factors that will determine whether you can use a dedicated cluster or whether you want to use an enterprise cluster, right? So the question, and of course we know that all of these decision-making criteria is subjective in nature, and it will be affected by a case-by-case basis, right? You don't have a one-size-fits-all solutions. That is very true, right? However, if you want to further this discussion, and if you want to scientifically formulate, let's say, an equation of some sort, or an algorithm of some sort that will help you with the decision-making process, account for all of these different factors that we are talking about, then how will you do it? Okay, so that's the question. And that's where we stopped last time. And I brought up the fact that I will ask you again this. So there we go. I did the recap. So where do we stop? So the two exercises that we want to do here is, of course, we want to learn about the lesson, right? Which is essentially how to formulate all of this into a scientific equation, right? But the other two things that you want to do is to apply your problem solving, okay? And while doing so, you need to be able to critically think for yourself. And to do that, you need to apply your knowledge, not just from what you're learning in this course, but what you have learned probably in other graduate courses, in your undergraduate courses, and stuff like that, right? So essentially, there is this, I wouldn't say theory, but this belief I have is that all of your core courses in some way play a role as you move towards your advanced courses, right? So you just need to find that correlation. It's like, how do I bring everything that I have learned in other courses and then apply it to something that I'm learning right now? So that belief kind of holds true with this current exercise that we are undertaking right now, okay? So the first question, of course, if you understand the question, everybody understands what we are trying to solve. So we want to have a scientific formulation about the decision-making process as which cluster should you use when you're building your own cluster for your organization, whether you should use a dedicated cluster or whether you should use a enterprise cluster, right? So we have some points in front of us, right? We have another important point, which is money, yes. But how do you put them all together? And how do you evaluate it? That's pretty important, because if you have an equation, right, the purpose of that equation is to be evaluated. So you need to kind of draw that out as well. So where do you start? What do you think of? So what are some of the key important things that is here? What is the main thing that we want to do? If you want to break down the problem that we have in front of us, right? Of course, you want to have a decision. Okay, and that decision making is basically about whether to use dedicated or whether you want to use enterprise, right? And how are most decisions in computer science carried out?
What's it gonna be used for?
What's it going to be used for? Yes. What else? If you have, let's say, a choice between two cars, how are you going to decide which one you will go with? Efficiency, power, okay.
Features, yeah, categories.
The
Rating.
ones that are important to you.
Just give me one, so to begin with.
Price.
Price, sure. All right. So you have the price. Let's say, give me one car model.
Supra,
Forget it.
A car model, make and model.
Toyota Supra.
Come on, man. You can do better. What else? Give me one more. We need one more to kind of mimic the two options that we have.
Preferably Corvette, of course.
Okay, I will take that.
Yeah.
Perfect. Who said that?
John.
Okay. You're currently my favorite, John.
Yeah. I work for the company, so that's why I'm.
Okay, you're more favorite to me now. We
Yeah.
can have a chat later on.
Yeah, sure.
Okay, price of a Supra. Give me some value. Let's say 50K. Whatever. Corvette 106.
All right. You know it.
Okay. So now, how do you choose which car do we go with? Of course, budget is a factor. You can always claim that. But what do you evaluate when you realize that this is 50K, this is almost a grand, like 100 grands, right? What do you evaluate from that point onwards? What does your mind go towards? I am spending 50K, and what do I get back for it, right? What's the worth of the money?
I would price to performance ratio. That would be
Right.
at least my criteria.
Yeah, the price to performance ratio. For what you paid, what you get back, right? You can take another example, for example, a choice making. You might not be that well versed in this, but let's say you're taking credit cards, right? And let's say you have one card and another card, where here you have to pay, let's say, $95 annually. And then you have another card where you have to pay, let's say, $250 annually. Now, if I pose you the question, which card will you pick? Right? Well, if budget is the main criteria, you will go with that. But if you take it a step further and do not make budget as like the linchpin of all your decision-making process, then what you have to do is you have to check that what do you get for the money that you pay, right? Some of the features you will like in the area or in the domain where the price is higher, right? So you might like some of the features here, you might like some of the features here. Okay, but you don't want all of the features in both categories. Okay, if that is the case, then it's all about budget at that point of time. But if budget is not the crucial factor, like the essential factor which makes or breaks your decision, right? So you will have to decide then whether you want to keep the best choices here or whether you want to keep the best choices here. What do you value more, right? And in CS, this process of decision making is kind of expressed in these keywords, which is known as optimization. Or you can say sometimes it is also called trade-off. So you want to pick the best choices out of the options that are available to you and then see what you can come up with, right? So essentially, for any kind of decision making in CS, you have to perform some sort of optimization. Some sort of trade-off is involved, right? You cannot get the best in everything. That's like the most ideal situation that you can, come across. But in more realistic situations, you will generally be facing some sort of optimization, right? So now, when we talk about optimization, right, essentially, the process involves in either maximizing something, okay, or minimizing something. Does everybody follow this? Right? So now, if you follow this, tell me one of the most simplest optimization algorithms that you are aware of. If you're not aware of the algorithm, then you can talk to me about the scenario where those algorithms are applied. So this is algo design and analysis. In undergraduate, maybe in graduate as well. What are the most straightforward optimization algorithms that you learned in algorithms? The simplest one. Forget about the divide and conquer, okay, but go further. DNC is a way to solve those optimization algorithms that speeds up the process. Yes, but there is a category of optimization which is basically iterative optimization. It's slow in nature, but it does the job for simple optimization tasks. Have you heard about these words? Greedy. Have you heard about dynamic programming? So this is basically the gateway into optimizations. Okay. So what you have to keep in mind is how are these algorithms designed? Because if you do not connect with them, you won't be able to connect with the higher order optimization algorithms that exist out there, right? So a very well-known example for greedy is basically the 0-1 knapsack problem. If you have heard of that before, right? And for those who are not aware, and to refresh your memory a little bit, is basically essentially if you are a thief, which you're not, but let's just assume you're a thief, right? And you have this bag. Okay, and this bag has a limited weight capacity. Let's say it can carry only 10 pounds. And then you go into a house, all right, and the house has many different valuable items, maybe from item I1 to item IK. And each of these items have a corresponding weight associated with it, right? So your job as a thief is to get the most valuable loot in your bag. So that means you want to maximize. So each of these items also have a cost associated with it, right? So what you want to do is you want to, as the thief, maximize the cost of your bag, but there will also be a constraint that is associated with your problem, is that it should not, let's say, cross 10 pounds. So that means the weight of the bag after you take your loot should be less than or equal to the threshold that has been that for the bag that you're carrying. Right? So now if you generalize this to a certain degree, all right, every optimization problem will have something that we call as the objective function. Okay, sometimes you will see the word objective function, other times you will see the word fitness function. But whatever you call it, at the end of the day, your goal is to basically either you want to maximize or minimize, depending on the nature of the problem that you're trying to solve, your objective functions. And in addition to that, you will also have some constraints associated with it, right? And the constraint should be don't cross the threshold of the bag weight in this particular example. Sometimes it could be you're working under a budget, so you cannot cross that budgetary constraint. So you will say whatever the total value is, it cannot cross beyond this point of time. Right? So now if you read between the lines, if you go back to this initial slide that we had, right now you can see that some of the things that we discussed can fall into these scientific equations at this point of time. And after that point of time, the evaluation part is up to the algorithm that you're using. Right? Also remember, when the number of objective functions are basically 1, then the problem is known as a single objective optimization problem. Whenever it is greater than 1, okay, 2 or more, then it is known as a multi-objective optimization problem. So when you go into the domain of multi-objective optimization problem, that's where you see higher order optimization algorithms. So some of the categorical optimization algorithms that are used quite often are basically genetic algorithms. Okay, so you might have heard across your research or some other course, hopefully, there are some algorithms, the popular ones like NSGA2. Okay, so these are all part of the genetic algorithm, but we don't have to worry about how exactly they are executed and stuff like that, or what is the design of those algorithms. But essentially what you have to keep in mind is whenever you are making a decision, especially in the cloud domain, right? Because this problem directly relates to the problem of cloud migration, where essentially you have to decide whether you want to move your entire organization to the cloud, or do you want to have a hybrid solution where a part of your organization's computing infrastructure needs to be kept in-house, right? Or on-prem, as we like to call it, and then move a part of it to the cloud, right? And if you do move it, then how much do you move it? What is the cost that is associated with it? What about the security requirements and stuff like that? So those are the decision-making that you will be involved in with work as a cloud engineer or a cloud architect, right? So this is basically the importance of the problem that we're discussing. It's in its simplest version right now. We're just making a decision on whether you should go with a dedicated or an enterprise cluster, right? So knowing this, what is it that we're trying to do here? What are our objectives? In this decision-making process, here we saw there were some suggestions that was made that how often do you need to do computationally complex tasks? So out of these points that you see in front of the slide right now, as well as some additional details that you would like to contribute further, can you come up with a set of objectives, whether they are maximization problem or minimization problem? That is also something that you decide. And then what are the constraints that will be associated? Now, one of the constraints should be very straightforward, right? It's in green. Ironically, I didn't even think about that, but anyways. So we can put that down. We can get that out of the picture. And we can say that whatever the cost is, I hope I can write it here, but I will take a fresh slide. So I will say here objectives. And I will say here constraints. Okay, so I know one of the constraints is the total cost of operations should be less than equal to whatever my budget is. So that's one thing that I can put in, right? But we still don't have any of our objectives. So Go ahead. Suggest some objectives. So two things you have to suggest whenever you're defining any objective is, of course, what is the objective? And that is going to be some sort of factor. Okay. And then you have to kind of decide whether that is a minimization objective. That is, are you trying to minimize that factor or are you trying to maximize that factor?
System must support the required number of users in the organization.
So you want to maximize the number of users that you can support.
Yeah.
That was the same.
Okay, so let's say UN, and I want to maximize this. What else?
Max computing power.
How do you define that? Max computing power.
Users of Nintendo.
Well, if you're trying to maximize the number of users, wouldn't that correlate to how many users you can handle as well?
Yeah.
Okay, but I still want to stick with that point. You want to maximize your computing power. This is for what? HTC or HPC? What is HPC?
Performance.
And HTC?
high throughput.
So this falls in the category of?
HTC.
Yes, HTC. Right, because in HTC, the principal paradigm is basically you want to meet as many user requests as you can per unit time. So if you're talking about supporting as many users as you can, then this falls in. But what about the domain of HPC? That is computing power, because in HPC, you need more computing power, right? But how do you kind of draw that out as an equation? Because you need something that is tangible. And by that, I mean, you can measure it, right? If you're plugging it into an algorithm or basically an equation, you need a factor that can be evaluated, right? Either through simulations or through emulation or actual scenario, right? So how would you evaluate performance?
It's like runtime of complicated tasks, like a task. How long does it take to execute?
You can just use like CPU speed.
Not speed.
Process speed.
Response time.
Say it again.
Response time.
Latency.
Latency. Yeah.
Latency be, yeah, response time, latency, RT or latency. Should that be an objective or should that be a constraint?
Should be constrained.
Objective.
Well, you want it to be as low as possible, right?
Right, but there will also be an upper bound on latency that you would like to specify as well.
That's true.
Of course, latency you would always want to, let's say if you have 0 millisecond, I'm like, amazing, right? But that's not the situation ever, right? So should that be a constraint? Everybody agrees? Okay, so I can say response time, let's say RT, which is also latency, should be less than equal to RT threshold. Now you can specify for your organization what that RT threshold is. Could be 30 milliseconds. It could be 60 milliseconds, not that great, but typically on an average, you know, for the everyday internet that you use in your houses, the basic starter packs, they have like around a 40-ish millisecond in the worst times, right? In the good times, you have like 30, 25, okay? Modern day intensive applications, like if you're talking about autonomous vehicles and stuff like that, they need a sub less than single-digit millisecond kind of latency for real-time decision making. So keep that in mind, just a side note, right? But that's good, all right? But still, performance. How do you express performance?
Can we say how many complex, let's say, equations can be solved through a unit of time?
Correct. So the word is not equation. When you execute a program, what do you execute?
Instructions.
Instructions. So
Okay.
the factor that you use to evaluate how much computationally intensive applications or processes you can support is
MIPS.
done by
MIPS.
this factor called MIPS, which is millions instructions per second. And how many millions instructions per second that you can execute will directly correlate to the computational power of your system. Does everybody follow? Okay, so you want to maximize this essentially in order to satisfy both HPC and HTC. Okay, what else?
Will availability and downtime be factors here?
Tell me, objective or constraints?
Availability, like we want to maximize the availability and.
But again-
Downtime, and there will be some numbers associated with it, like that we can put in constraint by the organization.
Okay, so it should be in the constraint. That's what you're saying.
Yeah, can we?
Okay, so let's just say availability and package downtime into it. Higher the down availability, we will kind of say that proportionally, inversely proportional is the fact that downtime will be less, right? So that should be less than equal to whatever the threshold is. What else?
Let's say again.
Say it again.
What's
Availability. Not autonomous vehicle. What else? Think about it. Don't just think in terms of computing, think in terms of people.
Need.
Say it again.
Need. If you don't need high performance computing, you don't get high performance computing.
Okay.
User experience. I mean,
Okay.
how do you make that into an objective?
So there are two aspects. There is quality of service and there is quality of experience.
Yeah.
Okay. So there's QoS and there is QoE. Okay. So QoE falls in the UX part of it. But what we are dealing with right now is mostly about the QoS aspect of it. That is, what is the quality of the service that you get, right? So response time, availability, these are a part of the QoS parameters. What else? If you bring up new stuff,
Can
Security.
one thing, security.
it must be. Not can it be, but always remember, whatever you're working with in this day and age, if you cannot think in terms of cybersecurity, that does not reflect well on it. Okay, doesn't matter if you work in the domain of cybersecurity or not. That is not the main thing. So even if you're designing something, if you're developing something, right, you should still have security in the back of the head. So what do you want to do with security? You want to maximize or minimize?
Maximize.
How should I express it? So here we saw the MIPS thing, right? So how should I express security?
Minimize vulnerability.
But how do you measure that?
Number of exploits per, let's say, certain amount of attacks.
But when you're designing the system, how would you know that?
You minimize intrusion.
Minimize what?
Intrusions.
Intrusion. I'm going more towards a computational aspect.
Ah,
Minimizing intrusion, yes, you can do penetration testing and you can
Downtime, maybe.
say that again.
The downtime.
Downtime we packaged into availability. So that's kind of together. We're assuming that. You can choose to have a different downtime aspect. There's nothing wrong with that.
Access.
How do you measure access? You see what I'm saying? It's like all of you are right. You're not saying anything wrong, right? But it's just like here, from a scientific perspective, if you want to run an algorithm on top of this, you need a factor that's measured. I can measure the number of users. I can measure MIPS by looking at the programs that I want to host, right?
To measure the amount of rights they have, access rights, least privilege.
How do you measure that?
I don't think like, is there a measurement?
Yes.
We have like both.
So when you are trying to evaluate the security of the system that you design, there are two factors. One is known as the likelihood, and the other one is known as the impact if there is a successful attack. Both of these are probabilistic in nature. And there are frameworks that can help you do this evaluation based on what you are trying to or what you envision to implement. Right? So what you want to do is you want to minimize. So when you say you want to minimize the number of vulnerabilities or you want to minimize the number of intrusions and stuff like that, what it essentially boils down to is you're trying to minimize the likelihood of different attack vectors that can be present on your system. Does that make sense? Does everybody follow? Right? So you want to minimize the likelihood. And you can run another objective functions where you say you want to minimize the impact, or you can bring them together and you can say minimize the risk. And the risk factor is basically a composition of likelihood and impact. Right? But you get the idea at this point of time. So whenever you are in a situation in this domain, and especially if you continue to work in the cloud domain, you need to be good with optimization. So you need to know what are the basic optimization algorithms, and you need to know some of the higher order optimization algorithms as well. Okay. Certain things cannot be solved by machine learning. I mean, it can be, but it's not required. It's like using a nuclear bomb to kill an ant. You don't want to be that person, right? Not everything can be solved. Well, I keep on going there. Don't use to solve everything, machine learning to solve everything. That's not the answer to today's problem, right? There are things like ChatGPT, outside, like stuff like that. Yeah, sure. But anyways, think fundamentally first and then build on top of that, right? Life will be much easier and simple. If you want to know, there was a good junction back in the computer architecture days when things were just evolving at that time, right? There are two philosophies on how the architectures of different computers could be improved in terms of speed of execution, right? So there was this one philosophy that was known as CISC, C-I-S-C, and there was another philosophy that is known as RISC, right? R-I-S-C, so reduced instruction set and complex instruction set architectures. So read that up and ask yourself, what would you have supported? That will again kind of, help you think, so to speak. But anyways, know the simple stuff. That's basically the moral of the story. Okay. Don't just say ML, DNN, reinforcement. Don't do that. Okay. All right. So everybody gets the idea. So if you're ever in a position where you have to make a decision, your decision needs to be factual and scientific in nature, right? Of course, you can have the meetings of money and stuff like that, but whatever you suggest, whatever you design at the end of the day needs to be tangible. And by tangible, I mean, you should be able to measure it, because there are algorithms in place, which if you plug in the tangible factors to, they will do the job for you. You don't have to sit down with a pen and paper and think, all right? So that's something that you have to keep in mind. Okay, so based on that, you have to know that there are certain things whatever you choose, right? Dedicated cluster or a mixture of the two, you can always have something that is hybrid as well. Scalability is the most important. Even in cloud computing, as this evolves into cloud computing, things needs to scale, all right? Because that is the demand of modern day applications. If whatever you design, the system that you design, the network that you design, if it's not scalable, if it's not modular, then nobody's going to appreciate that, okay? The other thing, when you're dealing or when you're working in this domain, that is starting from computer clusters, then going into cloud computing, you always have to remember how the single system image works. Because what is important is for your end users to not know what your underlying infrastructure is. That is the concept of transparency, right? And in order to implement that, you need a software that can do this for you, right? And that software is essentially known as a middleware. Later on in cloud, when we are working specifically with cloud, it is known as a hypervisor. Okay, so but earlier in the days, when people understood that this is required, it was not as straightforward. It was kind of a non-trivial task to be able to implement this single system image ID, right? So you have to keep that in mind, right? Availability was brought up. Anything that any computer networks that you design, right, which is supporting users' application must be available. If every other day it just goes down, then what's the point? Nobody's going to trust it. Your reputation will go down and people will move away to other services, all right? The other thing is, how do you schedule your jobs? This is also the domain of distributed computing, right? Even if you have, let's say, a dedicated cluster where in this whole room, you have different racks and you place all the computers together, you still have to make a decision, you being, let's say, the middleware or the person who is responsible for performing the administration, that given a user request, when it comes, which node is going to handle that request? That is an important, right? And even basic operating systems of every local machine also takes care of this decision-making process, like who gets how much resources for how long, make sure that thrashing is not happening and things like that, right? So it is like a combination. This job management is a combination of essentially scheduling and distributed computing. Okay. And then the last thing is basically when you have multiple nodes which are connected together by the LAN, wireless is never suggested unless that's your last option, or you are working in a domain which is wireless, like wireless sensor networks. That's a different story altogether, right? Communication is a major drawback. Because anytime you are going outside of your boundary, right, there is some sort of latency that is introduced. Even if you are having nodes which are hosted in the same room, think of a node that is at this corner versus this corner. The length of the wire that you have there versus the one of the neighboring nodes is always going to be longer, right? So some sort of latency will be introduced whenever you're designing these things, right? So how do you minimize that? How do you avoid that? Is there any possibility that you can do so? So these are some of the things that you have to keep in mind. And then finally, the last and the most important piece is to make sure that whatever cluster architecture that you design, which eventually evolves towards cloud computing, must be fault tolerant in nature. Okay. And essentially, so that's a question for you again, is that what is the most basic way of implementing fault tolerance for, let's say, a very local cluster that you manage? If you're working for the university's IT, right? Or if you're working for, let's say, a group of classes, right? And they need to execute simulation and stuff like that. So you're maintaining a cluster for them, right? So you have to make sure that you develop something that is fault tolerant. Or even for your research lab, if you have one, right? And you have multiple people working on stuff and you want to develop a cluster. So what is the most simplest way of introducing fault tolerance?
It was secondary physical machine where you back up to.
Okay, so basically the idea is to introduce redundancy. That is true, but how do you do it? What software, or not software, but what is available that helps you incorporate redundancy on the most basic level? Monitoring.
Imaging software, like if you have a virtual machine image, you can replicate that to a different machine very quickly, bring yourself back up online.
No one? I'll give you a hint. It's the name of a Thai movie, action movie, where a cop goes into the building and clears the entire group of bad people. It has two parts. But by the same name that you use here in fault recovery, it has 6 parts. It starts with an R. Not replication. I'm talking about the actual technology that is used to implement the idea of replication and redundancy. Say that again? RAID. Okay. Redundant array of disks. So that basically introduces redundancy. Then you can use that to monitor that. There are different levels of RAID, starting from RAID 0, 1, 2, 3, depending on how much redundancy do you want versus the optimal level of performance versus redundancy. Because remember, if you introduce too much redundancy or too much replication, what's the problem? Say it again. Latency, but there is another issue. Cost, yes. Accessibility. I'm looking for that last important thing. So if you
Data
have too many copies,
consistency. Data consistency.
the consistency.
Too much.
Yeah, that's John, right?
Yeah.
I remember. Anyways, it's good to hear your voice again. Wait, is that the Corvid, John?
What?
Were you the one who suggested Corvid as well?
Yeah.
Oh, okay. I didn't
Yeah.
recognize the voice earlier.
Yeah.
That's cool. All right. So the whole idea here is that if you do too much of replication, right, you also have an overhead in terms of management, because now you have to make sure that all of these redundant copies at the end of whatever time period that you are managing it must have the same copy, right? So again, there also, what kind of what level of RAID do you want to use is an optimization problem again, based on your use case scenario, because you want to find that sweet spot where you're not spending too much time trying to maintain all the copies, but you still have some level of fault tolerance, which is you're not compromising on that, right? So if you have redundant copies, you can use different techniques such as heartbeat, which is basically what Ryan suggested there, was basically monitoring. You check from time to time, and this is something that is pretty important when you have a decentralized scenario or a distributed scenario where things are far apart from each other, right? You also have the option of failover. So that means if you have some kind of failure on your primary disk, right, you can take that content and you can make whatever your backup copy is the primary. And at that point of time, there will be some delay with respect to the quality of service. Yes, because you're migrating everything, right? So, but it will not bring down your service altogether, right? If you just had a single copy and stuff like that. And rollback is quite similar to the concept of creating checkpoints on your Windows system and stuff like that, so that if something drastic happens, you have an image that is sitting there, which is, let's say, created every week, every bi-weekly, stuff like that, and you just revert back to that previous. So you lose some data, yes, but if you maintain logs, then you can recover some of that data as well, in addition to the rollback policies, right? So essentially what you have to keep in mind is that faults are not completely avoidable. You can do your best, yes, but there might be a situation where some sort of fault might happen in your system. But the philosophy that you need to follow when you're designing your system is the idea of graceful degradation. What I mean by that is basically, if you know that fault is going to happen and you cannot stop it, then you need to minimize its effect. So that's what we mean when we say that the degradation needs to be graceful in nature. So that means your website, whatever interface you're using to facilitate your service, might show some latency. It might take, let's say, instead of 1 second to refresh and give you the next web page, it might take 30 seconds or something like that. Yes, that is an annoyance, but your service isn't down. Does that make sense? So always keep that in mind, that whenever you're designing your systems, whenever you're thinking about fault tolerance, you need to make sure that you are using the philosophy of graceful degradation. And basically how you do that is by introducing duplication and redundancy. And there are many different technologies that are available. One of the most well-known is basically RAID systems. Okay. This is actually a movie, by the way. If you are doubting, you can check it out. The first one is good, the second one not so much, if you're a fan of action. All right, so based on this, based on all of these design policies, decision-making for computer clusters, there are 3 main types of computer clusters. And essentially this forms the backbone of the different types of services that is available on cloud computing domains as well, or what the current day cloud service providers provide. So the first one is compute clusters, okay? You will be familiar, if you have worked with the cloud before, that you have compute nodes on the cloud as well. Okay, depending on wherever you go, you have some compute nodes, right? So these are essentially responsible for HPC type tasks, but doesn't mean that you cannot use them for anything else, right? Any kind of computations that you want to perform, even if it is as simple as hosting a website, you can still use compute service, right? It's an overkill. Yes, you're not using all of its resources and capability, but you can use the lower, what do you call, spec compute cluster if you are just hosting stuff and things like that. But if you're using actual computation, or you want to execute computationally intensive processes, right? Engineering simulation problems and stuff like that, then you can use the higher spec computer clusters that are available by the cloud service provider. Okay, so this is the first category. The second category are basically the clusters that are made more available. Okay, so now if the purpose of your application that you want to host on the cloud or on these self-designed computer clusters is just to be available to the users, support as many users as you can, right? Then you want to make sure that the downtime of these computers is as low as possible. So that gives rise to your high availability clusters, which has a high degree of fault tolerance kind of embedded into them, all right? And then finally, although this is a category, when we talk about clusters, in cloud computing, this is an add-on to the high availability and compute clusters, which basically are known as load balancing clusters, right? So you don't want to stress out any particular node in your cluster or any particular node in your network, right? If that is the situation, and you know that because of fault tolerance, you have redundant nodes that are available for your purpose, then you want to balance out the different user requests that you're receiving in the computer network, right? So that's the whole idea of load balancers. It's a front-facing API that is there. It's a software that decides that once it receives various user requests, which of the underlying worker nodes should receive that request. Okay, remember in the last class, we discussed a bit about having 4 servers, 20 users going to 20,000 users and stuff like that. So that was an example of load balancing, right? And essentially, in the cloud, when we look into AWS, and the same applies to GCP and Azure as well, they have these add-ons of load balancers on top of any compute cluster or high available cluster that you're going to select, right? You can choose to have that, and you can set it up such that whatever you deploy is load balanced to begin with. Okay, so something to keep that in mind. All right, so the last thing of this chapter is essentially about the features of single system image implementation. Okay, so the few things, not few things, but let's talk about where you implement SSI first and foremost. Okay, so you have 3 choices. All right, you're going to learn one, unfortunately, because the others are not practical enough. Okay, they're doable, but they're not practical enough, and we will see in the next chapter why it is not doable. Okay, so the most popular option is the middleware option. Okay, so essentially, if you recall the structure of a traditional standalone computer, what you have is basically the all-encapsulating environment, which is your hardware. The hardware has some storage, memory, processing power and stuff like that. On top of the hardware runs your OS. Okay, and then on top of the OS, you have all your different applications that is running and requesting resources of the hardware, processing of the OS, and stuff like that. So the middleware is basically a layer between the operating system and the application itself. So this is where you are going to implement any kind of SSI image if you're just doing it with the help of a middleware. Remember, a middleware is nothing but a software. Okay, it's not a separate piece of framework or something like that. It's just another software that does something for you. Okay, so this is the most easiest one. Okay, and practically the most reasonable one, and it has the most suitable balance with respect to what can be achieved and how difficult it is to achieve that. All right, then you have the option for hardware or kernel layer. So a question before we move into this is, what is the difference between a kernel and an operating system? Anyone? You're all sitting with computers. Look it up. I still want the answer. What is the difference between a kernel and an operating system?
So the kernel is part of the OS. It doesn't interact with it.
So what does it interact with?
The users.
Not the users, the hardware. So basically, kernel is the lowest level of an operating system, which is in direct contact. So the kernel is somewhere here. Okay, and it interacts with the hardware resources, the underlying hardware resources. There is also a front-facing part of the operating system, which basically is responsible for taking into account the requests that are made by the applications with respect to resource utilization, right? And then it forwards that information to the kernel, and then the kernel makes the final communication with the hardware and then returns the request back, the response essentially, right? So that is basically the difference between the kernel and the operating system itself. So when we say that you can either choose to implement the SSI on the hardware itself that is embedded within the hardware, or you can choose to implement it on the kernel, so you know now where that kernel is. But what is the problem with this? In terms of performance, this will be the best actually. But it is difficult to implement. Can somebody tell me why?
It's your hardware dependent.
No.
Hardware specific, you'll have. to
Right.
write it
So
for-
remember, hardware is to a certain degree proprietary in nature, right? And if you're modifying the hardware, then you have to modify all the hardware that you add on to this network, right? So not just adding or embedding this is going to be a difficult task, but every time you want to grow, in terms of scalability, then you have to modify all of the hardwares that you add. So this whole logic that scalability was improved due to using of commodity hardware, that is everyday hardware that is sitting around us, right? And just adding that to our network and letting it grow will be defeated. Because every hardware that we kind of procure, we have to modify it and implement our single system image on top of that, right? But however, in terms of performance, it is the best because there is no intermediary
Fast.
directly communicating and working with the hardware, which is what essentially you want in terms of resource allocation, right? And then finally, you also have an option for implementing SSI on the application layer, which is basically in this location, the app level itself. So if you think of web servers, database servers, and stuff like that, they're all different applications that are running. Okay, so if you want to create an image of that database and provide it to different users, then you can do so. Right? So that is the simplest, but people don't use that much, right? Unless you're using software as a service, and then you need to create the containers on the software level itself, then the SSI is implemented in the application layer itself. Okay, whereas these two are the options for infrastructure as a service. All right, and we will talk about that when we cross virtualization at that point. And remember the features, if you are writing your own SSI, or if you ever encounter a situation where you have to write your own SSI, is the fact that everything needs to be transparent. We can just wrap all of these points into one single feature, is that you need transparency. So that means the user should not have an experience where if their job is being deployed to multiple different nodes, they have to access and log into each of these nodes one by one and then execute their operations, right? That should not be the situation. They should not see different file systems. Let's say if the underlying platform or systems that is there are using different operating system, the file path is going to be the different, right? Windows shows file path in a different way compared to Linux, compared to Mac, stuff like that. But when you are providing your services as a network, right, as a cluster, the user should not be aware of those differences, right? All the administrative tasks by the user, okay, not in terms of the service provider's administrator, that's a different issue, should be done from a single location, right? So that kind of brings together this single entry point and this single control point together. Okay, so these are some of the things that you have to keep in mind. So memory space, process space, and IO space, along with file system. Where is file system? Here, file hierarchy. So these are all resource transparency. Okay, this is basically control transparency. I should not be able to know the underlying structure that is there. The networking scheme that you're using should be consistent, right? You should not use different networking protocols across different clusters that you have in your entirety of your system or your platform. And then the job management system should also be controlled by the middleware. You should not have multiple entities deciding how the job works, right? So kind of boiling it down, basically it's all about transparency, and any kind of aspect that you implement within your clusters needs to be hidden from the users. Okay, so they should have basically a seamless experience that they are just dealing with a single local computer. That is what you have to do. Okay, so that is something that you have to keep in mind. All right. So that concludes computer clusters. All right. So the important things is that you have to remember what are the important design aspects that are involved when you're developing computer clusters. What are the different classifications of computer clusters? Okay. What are dedicated clusters? What are enterprise clusters? What are their features and stuff like that? How do you make a decision on what to choose, right? Whether you should choose dedicated, and how do you solve that problem, right? Essentially, those are some of the things that you have to keep in mind. All right. So any questions? Maybe not now, but as you revise, if you have any questions, always feel free to let me know and we can have a talk. Okay. So going back, before we move on to what is the thing called? Sorry, virtual machines. Let's have this discussion first. Where is this? Where are my notes? Here. No? Here. Okay, this guy. How do you figure this out? Where do you start from? Right? What is the systematic way of getting to the point where you can evaluate the likelihood and the impact? Of course, you have to know a framework, but before that, you also have to know the canvas that you're dealing with of different types of security risks that can be present to your network, to your system, even to your code that you're trying to write, right? So with that in mind, the discussion that I want to have is with respect to, what is this? Cybersecurity. Okay, just to give you an idea. So the first question in cybersecurity, so basically what we're trying to solve is how do we get to the point, this is getting to the point symbol for me, emoji, right? Where you can evaluate the likelihood and impact of risks, either on your network, your system, and your stuff like that. Paresh?
Okay, so the more modular answer would be is to do a risk assessment report.
Correct.
And if it's going to be done practically, this should be done using cybersecurity methodologies to test that certain field, let's say, of the system.
True. Correct. But for those who are unaware of this, how do you get to this point? Where do you start? What do you need to know in terms of the basics, right? So there is something when we start in this domain of risk assessment, okay? This is a domain which requires you to have both breadth as well as depth. Unlike working with specific security protocols, where you only need depth on a specific whatever you're working on, if you are a risk assessment, if you're working with that, you need to know both the breadth, the width, as well as the depth as well, right? So this is kind of like a unique view, right? But it's a game of chess to a certain degree. So if you enjoy that kind of activity, then you might enjoy this, right? So, but where do we start? That's the question. So there's a thing called the pillars of cybersecurity. Okay, in terms of assessment, remember, whatever we're talking is everything is in terms of assessment, right? So when you're assessing something, you have to assess, and that something basically is either a network, it could be a system, it could be a computer in itself, right? So I'm just embedding that in the system itself. It could be a program, an Android app or a web app, whatever it is, right? Whatever, that is basically what my something means. That's not the best phrase, but you know, that's what I've come up with. All right. So if you want to assess anything, how do you assess it based on, or what do you assess it against? Right? You need to ensure that certain security features or properties are intact. And then you can check based on your organization's business goals and stuff like that, which of those pillars are more important. But actually, all of them are important equally. But you need to kind of be able to assess that. So that's your starting point of your assessment, is to kind of be able to identify or be aware of the fact that whenever you design a system, okay, or a network, you need to ensure that your security aspects on these pillars are very strong, okay, very, very foundationally solid, right? So they are known traditionally as CIA, not the agency. But can somebody tell me? Should be straightforward.
Confidentiality, integrity, authorization, authentication.
Availability. So the traditional one was still availability, and then two more got added after that, which is authentication
Authenticity.
and authorization. Okay, no, it's not ATH, but auth. Authorization and authentication, right? So you can say that there are either 4 pillars. You can combine these two together, or you can say that there are 3 pillars, because the factor of authentication and authorization also plays into the subset of C and I, if you bring it together, right? So it depends on how you want to treat them when you're doing your assessment. So to write it down, you have confidentiality, integrity, availability, and then I will just put it here, authorization and authentication, right? So what are you trying to protect in the category of confidentiality?
Data.
Data, personal information, and what do you want to ensure there? You're trying to
Data
protect
would
those
not be
resources, yes?
accessed. The data would not be accessed by people who are not authorized to view the data, right?
Right, so
Right.
you see now, if I write this down, so no unauthorized access. If you need to know if whoever is accessing your data is authorized to do so, what do you need to implement? You need to implement first authentication so that you know who is who, right? And you need to give them access depending on who they are, which is essentially authorization, right? So that's why I said that the traditional ones are CIA, and then authentication and authorization is essentially embedded in this, depending on that, right? But the main aspect of confidentiality, if you want to rephrase it, is basically, how do you spell concealing?
CONCEAL.
Let's just deal with this. It's wrong here. I gave up midway.
EALI.
CA
CONCEAL.
CON
ECEAL.
CEAL.
ING.
There we go. Not this ceiling, but concealing. That's the idea, right? Thank you. All right, so that's what we want to essentially do, right? We want to conceal the information, keep things confidential, right? And of course, the act of doing so is to make sure that nobody who is not authorized to access it is able to access it, right? Can you give me an attack scenario where there can be a breach of confidentiality? What's the most simplest way that a breach of confidentiality can happen? Let's start always with the simplest stuff. Simple things in life.
Most of it uses your computer.
Okay, someone else
uses
uses
your
my
files
computer.
that they weren't supposed to see,
Okay,
using your credentials.
Simple password.
simple password. Okay, so that gets hacked. Okay, figure out your password. Anything else? What about, so there are two. Okay, so most of the stuff is about the data. What is the currency that a hacker or a rogue actor is trying to exploit?
Personal information.
We can just boil it down to data. And there are
Yeah,
categories
data.
of
Yeah.
data that we
Okay.
get, right? So I can say that the most important currency in the digital world is basically data. And there are many different kinds of data. You can have personal information, you can have medical records, you can have credit card information, stuff like that, right? Financial information, all those stuff. And then a secondary resource that is important is basically the resource itself, or we can say the computing infrastructure. Okay, but let's focus on data. There are two situations that can happen with data. Basically, data can be at rest, and then data can be in transit. Okay, so these attacks that we talked about, that it was unauthorized access to your computer, you just left it unattended and stuff like that, figuring out your password. This is basically exploiting the data which is at rest, right? But there is also another aspect where data is in transit. So how can you lose confidentiality, or how can there be a breach of confidentiality when data is in transit?
Man in the middle.
Man in the middle, right? So there is a very simple attack that is known as MITM, or man in the middle, right? And man in the middle can be avoided by making sure that what? Encryption, right? Encryption is one of the most straightforward ways to protect against man in the middle. Okay, so that is why the medium that we use in the current internet, the HTTPS, is basically encrypting the channel from the sender to the receiver to make sure that there is no snooping or eavesdropping that happens, right? So man in the middle can also be called up as snooping, as eavesdropping, and stuff like that. Okay, what about integrity? What does it try to protect?
The data process not be changed, basically, not going messy.
Okay, so that we can call it as non-tampered. How do you ensure your data is non-tampered?
Hashing algorithms.
Okay, that's basically the solution. Hashing algo, which is similar to saying that you can use encryption, not just to protect in transit, but if you somehow have encryption, then there is an additional layer of security that you introduce for your computer as well. So maybe I can figure out your password, but then there is another application that encrypts my data. So if I don't know the password to that, then I cannot go into your data, even though I have access to your computer, and I can do some weird stuff, but maybe not get your data, right? So hashing algorithms is basically a way to ensure that integrity can be checked, right? So hashing algorithms in conjunction to what is also known as digital signatures or certificates can allow you to verify the source of the information and verify the fact that whether that information has been tampered with or not, right? And as a result of that, you can ensure whether the integrity is in place or not, right? There is another way of making sure that integrity is intact is to authenticate whoever is handling your data. If you have faith in your authentication mechanism, knowing the fact that whoever you allow to handle your data is going to be the rightful person, right? Then it doesn't just address confidentiality, but it always also helps in making sure that integrity is in place. Okay, what about availability? Availability, as I like to call it, is the act of trolling. Okay, it doesn't go after the data per se, but it goes after this secondary resource that we were talking about, the computing infrastructure itself, right? If there is no service, then what's the use of the data? And that's why I call it trolling, because, well, you don't go after the actual currency, but you just want to cause frustration and annoyance, right? So what are some of the attacks on availability?
DDoS.
Everybody knows that. Is this because of the gamer syndrome? So you have variations of it. One is denial of service, and one is distributed denial of service, right? So what you do is you overwhelm the server with bogus requests, right? So that when the actual authentic request comes to the server, it will no longer have the bandwidth or the capacity to handle those requests anymore, right? So those are some of the ways. How do you solve it? So we talked about encryption here, we talked about hashing, digital certificates, blah, blah, blah. How do you stop DOS or DDoS? Simple way and
Preferably configure the server to accept few requests from a certain origin without causing a termination for the connection. Timeout, exactly.
So you can time out if you're getting too many requests from a single source, right? So that is one of the ways. There are also verification services. So for example, if you've heard about Cloudflare, that's basically one of the third-party as a service, solution as a service for security that is used by many service providers, which checks the IP which is connecting and see if it is blacklisted or whitelisted and stuff like that in order to prevent these kind of attacks, right? So that is one of the ways that you can deal with it. It's not foolproof, but it's doable, right? What other ways? Let's say, sorry? Captcha. Yes, you can do captcha as well. That will make sure that bots are not, what do you call, dealing with your service, essentially. So you can also say captchas, right? So most of the existing captchas are broken. Remember that. People have even come up with bots that can do signs, write their name, stuff like that. So now, GitHub is using a different nature of captcha. If you have noticed it, you have to like turn the picture, put it into part of the puzzle and stuff like that. But I also saw a video where, there was a robot arm with a pen that understood what is happening and they solved the captcha. Right? So it's always a game of chess, essentially, right? Who can get the upper hand over it? It's fun. Okay. So these are the different pillars, like the different types of attacks that can happen on these pillars. And when you're doing the assessment, what you have to ensure is, of course, you have to evaluate the likelihood of different vulnerabilities that can be exploited or different attacks that can happen. but you have to evaluate the impact on these guys. Essentially, what's the final impact, right? Depending on the framework that you're using, they have their own formulas that allow you to do those computations, right? So for this, you also have to know what different types of attack that can take place and how those attacks can be executed, all right? So these are known as essentially attack vectors. Okay, they're known as attack vectors, and they try to exploit what is known as the attack surface. So every resource that you have, program, system, network, whatever, we call or we kind of evaluate that how big or how small the attack surface is, right? So if you have a very bigger surface, then the potential of these attack vectors landing or getting an access into your application or your system is also higher, right? That is kind of self-explanatory. So that is our goal through these evaluations, is to reduce the attack surface. So if you reduce the attack surface, then the chances of attack happening also reduces, right? So the attack vectors can be categorized into two different domains. The first one are internal in nature. Sometimes you call it insider attacks, right? And the second one is external in nature. That is attacks that is coming from outside the system boundary, right? So in the current generation or the current assessment frameworks that we have, we always have this concept of trusted boundary, where we are saying that anything inside that trusted boundary is something that is within the control of the security administrator, and they have control over it. So they trust the operations that is going to happen within those trusted boundaries. Okay, and then anything outside the trusted boundary are considered to be malicious in nature by default. In contrast to this, there is a new paradigm that is up and coming. And this is one of the project topics that is there. There is a concept called zero trust that is up and coming, where they are doing away with this idea of trusted boundary, and everything is considered to be non-trustworthy or untrustworthy. Forgot what the word is, but you get the idea, right? So that's why they are merging this internal and external, because what used to happen in previous research is that people used to deal with internal, and they used to just, based on this trusted boundary concept, just assume that you are safe from the internal attacks, right? And then there were some other research works which basically said that, oh, everybody deals with external, we will deal with internal attack. So case in point here is, let's say you have a computer cluster, you have 3 different ones, let's just say 2, okay, and this is the entirety of your computer clusters, right? So any kind of communications that is coming from outside, right? What are the 2 types of communication that you can have in computer clusters? 2 category of communications. Again, everybody has computers. Well, it's majority of you. Just browse through the slides to check. What are the 2 different categories of communication types in computer clusters? Check the slides, it's there. Finding information is also a skill. Exposed and nobody found it yet? Louder, please. Okay, so exposed and enclosed. What exposed essentially means that you're using the regular TCP/IP protocol, the internet protocol that is out there. So you don't have to define your own protocols. You can just use what is there. So that also makes your system basically vulnerable. Well, vulnerable is a strong word, but you get the idea that outside world can communicate with your network. Essentially, that is what it means, right? So that is the situation in all the attacks that is coming from outside. You can say that this is your trusted boundary. But what if you have a situation here when one of these nodes are malicious in nature? Right? So how do you detect a malicious node? That's the first question. You understand, I don't have to explain that a malicious node inside will be an internal attack, and any kind of nodes that are interacting with your computer cluster, maybe this is a user computer, right, is going to be an external attack if this is a adversary or a rogue actor, right? So moving on to the next course of discussion is that, let's say you do have a malicious node, how do you detect that? And if you understand the drift of the discussion, the next question would be, how do you prevent that? So let's tackle the first question is, how do you detect if there is a malicious node present?
Monitor that.
Okay, and how do you monitor? Or what do you monitor?
Slow performance,
So performance,
The network it is trying to.
high CPU usage,
high CPU usage, slow performance,
Requests.
requests that you're receiving from time to time, and all those things, right? How do you monitor? What are the different ways of monitoring?
Agents.
Log in. Who will monitor? Let's put it this way.
Automated agents and software.
And where will they be?
Nodes
Which one? The one that is already,
inside the boundary, the ones you have control
but one of them could be malicious.
yeah, intrusion detection systems.
Right, intrusion detection system, the other nodes, right? So you have multiple options of where the monitoring is going to happen. So you can have what is known as a cluster head. That is a representative node of the entire cluster, depending on how you are administrating the particular system, right? Or particular cluster, essentially. So you can choose to put it in the cluster head, or you can choose to put it in the neighboring nodes, right? So these mechanisms of kind of keeping a track or monitoring or detecting is done by what we call as intrusion detection systems, IDS. Okay, this is not an O. Right, and one of the ways, one of the more popular ways of intrusion detection system in such networks is known as the watchdog mechanism. So what you do is that you give your neighbors the responsibility of spying on each other. Okay. Which is basically the CCTV method of like overpopulated areas. For those who got it, got it. Okay, but essentially, if you're my neighbor, I keep a watch on you too. You keep a watch on the rest and stuff like that, right? But of course, detection is one of the ways. There is also, so this is basically the category of detection. Okay, but there is also a category of prevention. As a security architect, you would always want to prevent something from happening rather than detecting it and then addressing it, right? Because at that time, if the attack has already happened, your only course of action is to stop the bleeding, right? Minimize the damage at that point of time. But you don't want to go there, you want to prevent it, right? That's the whole idea of why we take vaccines and stuff like that, right? So how do you prevent a malicious node from being a part of your network? Right? So again, go back to the parent categories. The double A's, authorization and authentication. So remember, authorization is done through access control. The method that implements authorization is access control. Okay, and one of the most popular access control mechanisms that are even used by cloud service provider nowadays is known as role-based access control, or RBAC. Okay, that's what AWS uses specifically, right? So we will learn when we are working on identity management, or basically there is a service on AWS that is known as IAM, or Identity and Access Management, which helps you define roles. Roles are essentially your access control mechanisms, and then you take these roles, which are essentially policy documents written as JSON files, and they're attached to the service that you're creating, such that those services can then interact with other AWS services when you're building your own whatever you're trying to do, right? And then you have authentication, okay, which is another mechanism to make sure that whoever is a part of your system or your network is authenticated. How do you implement this? So we know that now we have had this discussion that authorization is implemented through access control policies, and one of the well-known ways is role-based access control. But how do you implement authentication?
Using two-factor authentication, tokens, biometric data, and so on.
Okay.
Certificates.
All right, let's put it
Key-based authentication.
one by one.
Username, password.
Okay, so we will just say username and password, just to give you the upward trend. Don't say username anymore. You want to say user phrases. Okay, that sheds a better light on you. Okay, we are moving away from that username thingy slowly. Maybe not in 10 years, but we will get there. All right, what was the next one?
Keys, using keys to authentication.
Okay, key base. What was the other one? Biometrics.
Biometrics.
Two-factor authentication.
I will just say MFA. Okay,
Yeah.
multi-factor authentication. 2, 3, you decide what you want. But essentially, MFA right now is implemented more or less everywhere. Wherever you see, they will require you at least 2. Okay, you can have 3. Or you did it. Okay.
Are the key base are the same as the tokens?
Yes.
So
Yes, you can even generate certificates and stuff like that. So this one, the key base, is essentially keychain management or key management that you can do on the cloud. Okay, so that is one of the similarities in AWS itself, right? So when you do your evaluations, you are essentially trying to figure out how many different attack vectors are possible depending on the security that you implement, and then estimate a probabilistic value depending on the framework that you use for your assessment, and see what is the likelihood for these different types of internal and external attacks, and then what is their impact on confidentiality, integrity, and availability. Take it to your bosses and see if they like it or not. Right? So we will wrap up here. And in the next class, which will be online, 5:30 p.m. on Wednesday, we will start discussing the next chapter, which is virtualization. All right.